All right, we are started recording. We're going to do the classic calculus problem that kind of almost all engineering calculus classes do right at the beginning of learning about the derivative. So we're going to have Hal throwing a ball off the roof of a building. You guys have your notes out. I know you do. You're going to write stuff down. And the height of the meters, a height in meters of the ball from the ground is t after t seconds after they throw it. Like throwing, my hand is too close. Is expressed by this following function. So it's either Hal or height, but it's really height because Hal's not jumping off the roof. He's just throwing the ball. And I'm going to go ahead and actually just have everything out. So what kind of function is this, you guys?
Quadratic.
A quadratic, or parabolic is the other way to think about it, right?
Mm-hmm.
Okay. And it's written kind of backwards, right?
Yes.
Okay, so let's write it forwards so it's easier to see things. Does that look more normal-ish?
Yep.
Okay, so is it happy or sad?
Sad.
Okay, so we basically at this point know that it's a sad parabola, right? Like, we know that. Okay, and then the next easiest thing to find about the parabola is the intercepts, and I actually really like to do, I don't know, we can do either ones of them. Do you guys want to do the x ones or the y ones first?
Y.
Okay, you want to do y, because y is when x is 0, which in this case it's t. So if t is 0, then the y-intercept is that 250. So we've got this point 0, 250, but we don't know where it is on here yet. So we're going to try to put that in the right place in a second. And I hope this doesn't get in the way of other stuff. So that's our y-intercept. What do we do to get the x-intercept?
I set y equal to 0 and solve for t.
So we're going to get the x-intercepts. We're going to take this and set it equal to 0. So we've got the negative 5t squared plus 25t plus 250. And we're going to set that equal to 0. All right, so we were calling it x-intercepts, but it's really t-intercepts because this function is a function of time with t, so whatever. We factored it out, so that means either negative 5 equals 0, t plus 5 equals 0, or t minus 10 equals 0. So if t plus 5 equals 0, then t equals what?
Negative 5.
Negative 5. And if t minus 10 equals 0, then t equals 10. So that means that, let's put some ground on here. Here's our ground. We've got negative 5 and we've got 10, which already lets me know that this 0, 250 is going to be closer to this side. So let's put the building kind of right here that Hal is standing on top of and tossing the ball off of. Here's the building. And he's tossing the ball. He's standing on the edge. He's a daredevil. So we're going to make this be the y-axis, or the h of t axis. H of t, and this is going to be t. Okay, so this looks like the ball throwing, but it really isn't, because all we're talking about is the vertical height. Okay, so even though the ball does actually follow this path, we're not talking anything about flying in this direction. We're just talking about how high off the ground. So right here, we're going to label that 0, 250. Okay, and now I guess I should have done 10, 0, and negative 5, 0. All right, so first one, now we got to distinguish the main thing that I want to distinguish? Oh my gosh. When we're doing this problem is when we're doing algebra and when we're doing calculus. So, number 1, how high is the ball the moment it leaves his hand? Can you guys tell me where on the graph the ball is when it's leaving Hal's hand? So at time 0.
250.
250. Right there is where the ball starts its path. Okay, so how high is the ball at the moment it leaves his hand? Now, one of the things that I want to do here, in case like you just have a spaz moment, I want you to get in the habit of saying this is regular old algebra h of 0, so that if you do something spazzy, you can still get credit. Does that make sense?
Okay, so in office hours, I wanted to clarify the usage between algebra and calculus. Is that based on the actual physical properties that we're looking at?
Yeah, it is. So for algebra, that means you're just looking for something you can get from just using this equation. This equation gives you the height of the ball at different places. How high up is the ball? And if you're asking for velocity, velocity is the rate of change of height with respect to time. So like miles per hour, except it's meters per second here. So in this application, we're going to be talking about algebra is just the height of the ball. It's just plugging in like you knew in algebra. And then the new thing that you've learned in calculus is how to find the instantaneous rate of change, or velocity, which is the change of the functional value with respect to the variable. So the change in height with respect to time. And no matter what the function is, we'll do other functions later, it's the change in the y value with respect to the x value, t value, whatever. Does that kind of make sense?
Yes, that makes sense.
Okay, so in this case, it's just velocity. Sometimes it'll be, a growth rate of something else or whatever, but it's a rate of change from the first function to the derivative. So since we need, instead of algebra, we need calculus here, let's go ahead and see where I can do this up here. Let's do h prime of t. Am I still on the screen somewhat?
Yes.
Okay, and I think I don't like this order, and you guys don't usually like it this way either. This is just a standard way to write it for various reasons. So this is our function. We're not going to use the limit definition. We're just going to take the derivative of this. So let's go ahead and do that. Negative 5t squared becomes what?
I'm sorry, are we factoring?
No, we are, hold on, I'm going to pause. We
Deriving?
are deriving.
See,
So just with the power rule, the shortcut rules.
So negative 10t.
Yep, equals negative 10. Oh my gosh, why is my pen not working? Negative 10t plus what?
25.
Yep, 25, because the rest of this is basically linear, so it's just the slope of the rest of it, plus 25. So there is our, and this will give you, h prime of t is velocity in, let's see if I'm still on screen, meters per second. Okay, so that's velocity. Okay, here we go. So this one, we're going to use the velocity function because it's asking for velocity, which is also instantaneous rate of change. So at launch. So at launch, what time are we talking about?
0.
0, good. So we're going to do h prime of 0, which is negative 10 times 0 plus 25 equals 25. And it's velocity, so what are our units?
Meters per second.
Meters.
Good, meters per second, both of you. Meters per second. And I know that you have this teacher who's like kind of crazy about being really clear what your answer is, so I want to make sure you get credit there. All right, so when Hal throws the ball, his hand is 250 meters above the ground. He throws the ball, and its vertical velocity is 25 meters per second, so it's going up at 25 meters per second. And it's not its overall velocity, it's just the vertical velocity. We're only going to be doing 2 dimensions kind of here, so yeah, it's very simplified. Okay, now 1 second after throwing the ball, what is the height from the ground? Is this going to be algebra or calculus?
Algebra.
Algebra, yep, it's just the height. So when it's just height or position, height, it's just, oh wait, that's the wrong one, this one, height. So 1 second after, so what function do we need to use?
The original one.
H of what?
1.
H of 1. Okay, so we're going to plug that in. negative 5 times 1 squared plus 25 times 1 plus 250. So 250 plus 25 is 275 minus 5 is 2. All right, so we just plugged in 1. We did 250 plus 25, which is 275 minus 5, which is 270. So 270, and we're using algebra, and we're talking about the height. So what are our units here?
Meters.
Meters, good. So it's 270 meters. So we can probably even draw that in the messy graph if we want to. I don't know that I can do it neatly, but I'm going to try. So this is 1 and 270. Good, good? Yes? No? Okay, you guys are good. All right, I'm going to zoom out a little bit, move it up. Okay, so next one. 5 seconds after throwing the ball, what is the height from the ground? What are we going to do here?
Plug in 5.
Plug in 5 to what?
The original function.
So in my class, just writing this can save you. If you calculate wrong and stuff like that, just saying, tell me what you're doing, and then do it, and then give me your answer. This tell me what you're doing in my class frequently is half credit, and it really saves you if you make any kind of calculation errors. All right, so we plugged in the 5 to the function, and we remembered to square the 5 even though I forgot it first, and we added it all up. We got 250 meters. So 5 seconds after the ball has left his hand, we're at 250 meters, which means 5 seconds after we are right here. Does that make sense? You see what I just did? Whoop. Yeah?
Yep.
Okay, because that's when so it's gone up, it's peaked somewhere, and now we are at 5 to 50. Okay, so it's 2. Okay, when does the ball hit the ground? Okay, when does the ball hit the ground? Can we tell that from what we've got going on here, you guys?
T equals 10, right?
T equals 10.
Intercept.
Yep. Yeah, and that was when we had, we set y equal to 0, because we want the height to be 0, so we'd set y equal to 0. So the graph has lots of meaning to it. So, good. Does that make sense, Nazaria?
Yes.
Okay, so the intercepts are frequently fairly important. Like, this is where Hal's hand is when it launches. This is where it lands. And what's this one? Does this matter at all?
Nope.
No. Okay, it's before anything happens. Like, at 5 seconds beforehand, he was probably standing on the roof freaking out and afraid of heights. I don't even know. So, all right. So you guys say that this was 0 equals h of t at negative 5 and 10 must be 10. So when does the ball hit the ground? When does the ball hit the ground? So 10 seconds after launch, which is really silly to say launch when it's just a dude throwing a ball, unless it's a professional baseball player, and then it's okay. Okay, what is the average velocity of the ball during its flight time? This one might get you. We haven't done this a bunch. Average velocity of the ball in its flight time. Oh, wait, you know what? We didn't answer the second part of number 5. What is the relevant interval for this function? That'll actually help a lot.
Is it 0 to 10?
The relevant interval includes when it leaves his hand, and it includes when it hits the ground. So that's this answer. Okay. Then, okay, average velocity. First, algebra or calculus?
Calculus.
Nope. I'm so obnoxious.
Algebra.
Okay, good guess. And you had actually just explained it to me when we were off thing, and it was algebra. Okay, so we're going to use algebra still, because you had said it's something beautiful a second ago. What was it?
That we're taking the displacement over the time.
Displacement, so fancy. Displacement over time. Okay, so total displacement over total time. And I don't know why it's focusing on me there. Okay, so which is actually the same thing as, I can't do y2 because it's h 2, but height 2 minus height 1 over t2 minus t1, which is the same as what equation?
The slope equation.
The slope equation, right. And it's the slope of the secant line here that I'm going to try to like really gently draw in. Let me see if I can even do this. Probably not. We'll see what happens. Okay, so I made that line that we're finding the slope of. And if you can do it, if you can find the slope or rate of change using 2 points, then you can use the regular old algebra way that you've been doing for like forever. So you can do this. Okay, our H2 was 0 because here we were like on the ground at H2. What's our H1?
250.
250 is where it started. The ball started at 250, it ended at 0. It might have bounced, it might have made a hole in the ground, whatever. We're going to make it as simple as possible. Okay, and then the time was what?
10.
Yeah, it's 10. Technically it's 10 minus 0, but it's 10. We're all good. So it's negative 250 over 10, which is negative 25. And we're talking about average velocity, not instantaneous velocity, average velocity. So what are our units for velocity?
Still
Meters per second.
Yeah, both of you. Good. Meters per second. Okay. So if the ball had just fallen, the average would be negative 25 meters per second. But that's not really what happened. The path of the ball like went up for a while and then came down. So it's got to have speeds that are faster than negative 25 meters per second, because there's no way the average could be that unless some is faster and some is slower. Because it's going up here, it's not doing anything there, it's going down, stuff like that. Okay. Okay. Let's do, I think we have a typo. Hold on. Okay, so there wasn't a typo. We're back. What is instantaneous velocity? Instantaneous velocity of the ball 1 second after launch. So algebra or calculus?
Calculus.
Calculus, so I need blue. Okay. Instantaneous velocity. And it's calculus because exactly at 1 second, that means exactly right here. So there's not 2 points. So we can't use the slope. We would need to do that limit as h goes to 0, blah, 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 that thing, except now we know the shortcut, so we don't have to do that anymore. But the instantaneous velocity is like the speedometer right there. Does that kind of make sense?
Yes.
Okay, so instantaneous velocity, you're telling me it's calculus, and the way that you're going to tell me, other than you're not going to write calculus on your test, you're going to write h prime, and then I know that you're doing calculus, of what?
Of 1.
Of 1. Boop. H prime of 1. Okay, so let's just plug that in. All right, so we plugged the 1 into the derivative function. 25 minus 10 is usually 15. What are the units?
Meters per second.
Meters per second. Okay, so there we go. All right, instantaneous velocity of the ball 5 seconds after throwing. Blah, blah, blah. What is that going to be?
Calculus.
Calculus, yep. H prime of
5.
5. Good. Okay. So, which means we're right here, right? Does that, so we're going down, right?
Mm-hmm.
Okay. So, and I guess I should have written stuff on there. I'll try to get to it in a second. All right, let's start plugging in. All right, so we now have the instantaneous velocity of negative 25 meters per second over here for at 5 seconds in, which is here. So right here, the speedometer would say negative 25 meters per second, which is the same as the speedometer said at launch. Remember at launch right there? So right here, the speedometer was 25 meters per second. This is getting way too much of a hot mess. So, and there's symmetry in parabolas. So at the same vertical height, it was going up 25 meters per second, going down 25 meters per second. Does that kind of feel a little bit elegant or nice in some way?
Yes.
Yeah, because
A little
like
bit.
halfway between those 2 points would be the vertex, right?
Yeah, and we're going to get there. So halfway between 0 and 5. So what's it going to be?
2.5?
Yep, but we haven't found it yet, but we're going to. But you're right, the symmetry really helps a lot. And then we've got this 15 meters per second here that was right there that I'm not sure if I should even write because I feel like I'm just going to make it messier, but I think it's okay. So he threw it quickly. It's going up, but gravity makes it start coming down, right? So like all that. All right, we're going to go on to the next question. Unless you have questions about any of the stuff we've done so far, I'm going to move up. We good?
We're good.
Okay. Okay, so we're back. I folded the paper up so that we can just look at number 9. At what time does the ball reach its maximum height? Now, Mason just did some like logical reasoning and realized that it would have to be at 2.5 seconds. There's also the algebra way of finding the maximum height, that negative b over 2a, if you remember that. But then what we need to be getting into is the calculus way of doing this, which we haven't necessarily done, but there's going to be times when you're going to want to do it. And we've done it some in class, and they ask for it in the homework. But it's right here. We know that. We already know what it's going to be. What is the instantaneous rate of change right there of this function? Is it going
0.
up? You were right, it's 0, because it's not going up. It's not going down, right? Right there, ever so briefly. It's like hang time or whatever, you know what I mean? Does that make sense? Basketball, hang time? I don't know. So right there, the slope is 0. The instantaneous rate of change is 0. And what's the instantaneous rate of change? What function is the instantaneous rate of change? Calculus, the derivative, right. So right there, one of the other ways that you can find that place is using calculus. You can say this is where h prime of t equals 0. So you can do it with algebra or calculus or the reasoning that Mason just showed. So the derivative was this negative 10t plus 25. So negative 10t plus 25 equals 0. So if you subtract 25 from each side, you get, or actually, I'm going to subtract the 10t and put it over there so that there's no zeros. We'll get 10t equals 25, divide by 10, divide by 10, and we get t equals 2.5, which is what Mason had just said. And any place in a function in parabolas, there's lots of different ways to do it, but once we get to cubics or something like that, you can find all of the points, and that'll be later, chapter 4, not now. But does it make sense that the derivative is 0 there?
Yes.
Because it's done going up, but it's not going down yet. So we now know that the x value or t value is 2.5. Okay, and then what does it ask us here?
The max height of the ball?
And which function gives us the height of the ball?
The algebra one, the original?
The algebra one, the original one, right? Oh, my hand's all over the place. So I'm going to go back to pencil, because that's what I do for algebra is pencil. The max height of the ball at this 2.5 seconds. Well, we know it's got to be more than 250, right? But we're not sure what yet. So let's do that. We're going to do h of 2.5. Okay, and this is something you should be able to do without a calculator. The video is getting really long. I'm probably not going to record this because the video is getting way too long. So we're going to plug it in and calculate it. And if you can't do this with a calculator, come to office hours or something. Negative 5 times 2.5 squared plus 25 times 2.5 plus 250. I did the math when we did this in class, and I showed it all, and I want to know what you guys like. I don't see it. All I see is the answer. Damn it. All right, so 2.5 squared. 2.5 times 2.5. How would you guys do that?
I always stack them like I have to do multiplication like 2.5 over 2.5 with the little x and the line under it.
You do this.
That's how I was doing it. And then just bringing the decimal point down.
Okay, so 5 times 5 is 25. 5 times 2 is 10, which means we just do 10, right?
But you add the 2 from the 25 on top, right?
Oh, shit, yeah.
Yeah.
Thank you. So glad we're not recording it. Okay, hold on. Okay. Stop. Okay. 12. 5. And then 2 times 5, we put a 0 there. 2 times 5 is 10. Carry the 1, and we carried the 2 before. 2 times 2 is 4, so 5. Yeah?
Mm-hmm.
Okay. And then we add them. 6 to 5, and there was 1 decimal place here and 1 there, so it's 6.25, yeah?
Okay, yeah.
Yeah, see, I got the 625, but I just brought the decimal point down. But if I bring it down exactly where it is, then it's 62.5, and I was like,
That's what I did.
But then you know it's wrong because
Yeah.
it's too big, right? Because 2 times 2 is 4, and 3 times 3 is 9, so it's got to be between 3 and 9.
Yeah, I brought the decimal over.
4 and 9. Okay. Is that good?
Yeah.
Okay, so we've got -5 times 6.25 plus 25 times 2.5. Oh my god, I just fucking want to cheat. Okay. But you guys can do it, right?
I can try.
Times 2.5. It'll take some time, but you can do it. 25 times 2.5.
Wait, so this one would probably be 62.5, right?
Yep. Good. 62.5 plus 250. But then we need that 5 times 6.25. 31.25. 31.25 plus 62.5 plus 250. Yeah, so this is 250, 62.5, and 31.25. So we're going to add all that shit up. And we get 7.5. I don't think this is what I got in class. Hold on. Damn it.
I added the decimals first, and I got 93.75.
It should be 281.25. So I'm doing something wrong. Or I did it wrong in class. 2.5.
I just got 30.125, but maybe I added wrong.
Oh, for this one it's 30.125?
No, I don't know.
So 250 stays. 2.5 times 25. I think we did that right. 2.5 times 25. I'm cheating. 62.5. Yeah, that, and we both agreed on that one. And then 6.25.
Oh, it's negative 31.25.
Yeah.
So it is 30.125 or is 31.25?
Oh, so that one, I don't know. Let's see. 5 times 6.25. 31.25.
See,
Did you look at your thing and figure it out?
I'm redoing it.
Okay. So this is...
Oh yeah, I forgot to carry the 1.
6, 1, 1, 3, 12.5. So we've got 312.5 minus 31.25 Looking back at my picture to make sure we're going to get the right thing. We are. Oh, thank God. Okay, so we're going to get a 0.25 because 50 cents minus 25 cents is 25 cents. I don't know what the operations are. 2 minus 1 is 1. 1 minus 3 is 11 minus 3 is 8. 8. 3 would have become a 2. This would have become an 11. 2, 2, 81. Is that what I got in class? Yeah, this took way longer than it did in class. I don't know what I did in class. I did something else magical in class. Okay, equals.
The way I looked at it was it's negative 31.25, and that's half of 62.5. So then it's just 31.25 plus 250.
That was way better than what I did. Or
Smart, Mason.
Thank you.
there. Okay. Okay, let's keep recording. And people can come if they need to ask help with that. And I feel like you can all just struggle through it. It's just painful, and I got to make sure you can do some of it and not have all this eraser stuff all over the place. Okay, so let's see. Are we back? Centered-ish. Okay. Yes. Okay, so hold you closed. We're good. Okay, so what are we doing? Okay. All right, so now we've just found the ball's maximum height, which we found the vertex. We talked about doing it 3 different ways, whatever, we found it. And then the height there is just the algebra, which, you know, multiplying decimals, I have to make sure you can do it, but there it is. And if you got this wrong, you did h of 2.5, you showed me some of your stuff, and if you lost something somewhere, several things you'd figure out, and you also know it needs to be higher than 250. So as long as you get something higher than 250 and you showed me that you tried to multiply, you'll get some partial credit, because that's the joy of me grading rather than my math lab grading. Okay, so 281.25 meters. Okay, so max is there at 281.25 meters. Okay, so we've got the ball going up. We get the rate of velocity or vertical velocity by plugging things into the derivative, blah, blah, blah. Now, at the moment the ball is launched, at what rate is it accelerating? So what's acceleration? We've already done all this, like we know what velocity is. Now we need to figure out how do we get acceleration. You guys know?
The second derivative?
The second derivative. I'm going to use purple for the second derivative because I can. So acceleration is the rate of change of the rate of change, right? So it's not just meters per second, but it's meters per second per second. How much are you speeding up or slowing down? That's acceleration. So we're going to need, at the moment the ball is launched, so we're going to need f prime prime of what value? The moment the ball is launched.
0.
0. Okay. But first, let's find f prime prime. F prime prime. F prime is negative 10t plus 25. If we derive negative 10t plus 25, what do we get?
Negative 10.
Just negative 10. F prime of t, and it's actually h.
Okay, so we can say h, yeah.
Yeah. Okay, and this should also be an h. Can we make it be an h without being too much of a hot mess? I don't know if that's too bad. Okay, so the second derivative is now just negative 10, and it feels kind of weird sometimes because like there's nothing going on, but this just means that the second derivative is always negative 10. So no matter what, no matter where you are, you're slowing down at a rate of 10 meters per second per second. So equals 10 meters per second squared, which is a little, ooh, is my negative there? Negative. I might have to white this out before that's just too bad. Equals negative 10 meters per second squared. I'll white that out before I scan it for you guys. Boop, 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 boop. So then it asks, what is the acceleration of the ball after 1 second? What do you think it's going to be?
negative 10 meters per square?
Yep, no matter what. H prime prime of 1, H prime prime of 5, boop, boop, equals negative 10 meters per second squared, negative 10 meters per second squared, which if you've done physics, which I know one of you has, gravity on Earth is negative 9.8 meters per second squared. Sound familiar?
Yes.
Ish. But 10 is an easier number to deal with so that you cannot have a calculator. We need to pause for a second. Yeah, because at some point in time. All right, so I'm sorry during part of the video this part got cut off, but the derivative, the second derivative, is negative 10 all the time. The acceleration is always negative 10 meters per second, whatever planet this building is on. So do you feel like a little better about what is algebra and what is calculus?
Yes.
Yes.
Okay. All right, we're going to stop this for now. You guys can ask me to make more videos anytime about anything, and have a great day.